Hello, welcome to today's class. In this video, I will be talking about refrigerant nomenclature. Refrigerant nomenclature. Now, you all know that refrigerants are the working fluids of HVAC systems. Refrigerant is a very important liquid that we use in refrigerants, and I hope you all know about the various types of refrigerants. We have refrigerant R134, 134A. We have refrigerant 410, 410A. We have refrigerant 22. We have refrigerant 12, and so on and so forth. We have more than 100 types of refrigerants. And one way that we can identify refrigerants is by their code. Now, refrigerant 134A is one of the most commonly used refrigerants today. And the A you see here, the A represents isomers. All right, so you can see that refrigerant 134 has different grades. We have refrigerant 134B. Okay, now the R for refrigerant stands for refrigerant. The R represents refrigerant, stands for refrigerant. Okay, now the numbers 134 or 410 or 22, they represent the chemical composition of the refrigerant. In today's class, I'll be showing us different ways that we can calculate our refrigerant code, or I'll show us different ways that we can determine the chemical composition of our refrigerant, and also how we can determine the codes of refrigerants. So I want you all to listen attentively. If you have a question, you can leave the question in the comment box below. Now, I will start with how to find refrigerant code using the chemical composition. Now, we can find refrigerant code using their chemical composition. Now, we'll start with saturated hydrocarbons. Now, I hope you all know the meaning of saturated hydrocarbons. They are those hydrocarbons that contain single bonds carbon atoms. They contain single bonds carbon atoms. All right, so these are called saturated hydrocarbons. They contain single bonds carbon atoms. So we'll look at how to find the refrigerant code of saturated hydrocarbon using this formula. Using the formula here. Is the formula that we'll be using. The R stands for refrigerant. All right. The M minus one stands for number of carbon. Then the N plus 1 represents the number of hydrogen atoms. And the P represents the number of fluorine atoms. Okay. Now, these are the formula we use to calculate the refrigerant code of saturated carbon. I will show us an example just now. Don't forget the formula. Now, let's look at two examples of how to find the refrigerant code of unsaturated hydrocarbons. For example, we are asked to find the refrigerant code for this compound, which is given as Cl2 F2. Okay, let's find the refrigerant code for this compound. I call this my example 1. Okay, now let's find the refrigerant code for this compound. The first thing I do is this. I want us to note that the C here is your carbon. Your Cl is your chlorine. And your F is your fluorine. Okay. Now, as you can see right here, we have just one atom of carbon, We have two atoms of chlorine, which is 2. Then we have two atoms of fluorine, which is 2. Now, I will put in this formula, I will put in these numbers into my equation, which is R n minus 1 n plus 1 and P. Alright, so therefore, the refrigerant code for this compound is R. My N is the carbon, which is 1. So 1 minus 1. My N is number of hydrogen, so N is 0 because we have no hydrogen right here. So N is 0 plus 1. And my P is number of fluorine atoms, which is 2. So 2. Alright, so therefore, the refrigerant code for Cl2F2 is R. 1 minus 1 is 0, so it's gone. 0 plus 1 is 1. 1, then 2. So the refrigerant code for this compound is R is refrigerant 1,2. Is refrigerant 1,2 is the refrigerant code for Cl2F2. Alright, let's look at another question. Also, we are still finding the refrigerant code for saturated carbon. Example 2. We are finding the refrigerant code for CH, Cl, F2. In chemistry, we call this chloro, it's called chloro, difluoro, methane. It's called fluorodifluoromethane. In chemistry, that is the name we call this compound. Now, we shall be finding the refrigerant code for this compound. Now, I want us to remember the formula. The formula I said to finding the refrigerant code for saturated hydrocarbons is R, bracket open, N minus 1, bracket open again, N plus 1, and P. I say that N is the number of carbon atoms, the N is the number of hydrogen atoms, and P is the fluorine. And from this question, as you can see, from this question, we have one atom of carbon. Our carbon is 1. Carbon is 1. Okay. Our hydrogen is 1. This is hydrogen. Is one carbon atom, one atom. Our chlorine is also one atom. Chlorine is 1. Also, we have our fluorine. Our fluorine is 2. Now, I will log in these values into my equation, so I can say the refrigerant code becomes R, bracket open, my M is number of carbon, which is 1, so I put a 1 minus 1. My N is number of hydrogen atom, which is 1, from 1 plus 1. And my P is number of fluorine, which is 2. So therefore, my refrigerant code for this compound is R. 1 minus 1 is 0, it's done. 1 plus 1 is 2, then 2. So this is the refrigerant code for CH, Cl, F2, chlorofluoromethane. I hope some of you must have seen these refrigerants being used in most AC systems. Refrigerant 2.2 is being phased out because it has chlorine content. I repeat that, refrigerant 2.2 is being phased out because it has chlorine content. All right? Now, let's look at how we can find the refrigerant code for unsaturated hydrocarbons. Now, I want you all to note that unsaturated hydrocarbons are those carbons with double or triple covalent bonds between adjacent carbon atoms. So these are called unsaturated hydrocarbons. They have double or triple covalent bonds between adjacent carbon atoms. Now, the formula we use for finding the refrigerant code for unsaturated hydrocarbon is R, bracket open and close, 1, N minus 1, N plus 1, and P. As I said earlier, N is the number of carbon atoms. Let me write it out. N is the number of carbon atoms. N is the number of hydrogen atoms. And P represents fluorine atoms. So with this, we can solve questions. We can find the refrigerant code for unsaturated hydrocarbons. Now, let's find the refrigerant code for an unsaturated hydrocarbon. For example, let's look at an example. Let's find the refrigerant code for C2H4. C2H4. This is a refrigerant, and in chemistry it's called ethylene. Okay. So this is the refrigerant code for, this is the refrigerant name for C2H4. Now, let's find the refrigerant code. Remember that refrigerant code begins with R. So the formula I gave us here for finding the refrigerant code for unsaturated is R, bracket open, 1, open again, M minus 1, bracket open again, N plus 1, P. All right. Now, let's look at this compound. Now, the first thing I see here is that C is carbon, as you can see, is C2. And if you remember in chemistry, ethylene is hydrocarbon with more than one covalent bond. All right. So C is carbon, and carbon has 2. C is carbon. It has 2 atoms. All right. Then H is hydrogen. It has 4 atoms. What next? I am going to log this into my equation or formula. So we now have what? We have R 1, N minus 1, N is 2, 2 minus 1. Next one is N, N is 4, 4 plus 1. And our P, we have no fluorine atom, so I write 0. Because there is no fluorine atom, so we use 0, or you can take it off, but we use 0. Now, what next? So therefore, my refrigerant code for ethylene is R 1, 2 minus 1 is 1, 4 plus 1 is 5, then 0. So this is my refrigerant code for C2H4. Most times when you go to buy a refrigerant, you don't see this chemical name. What you see is the refrigerant code. So that is why I will advise everyone to take a very close look at your fridge, your refrigerator, and your air conditioners. Look at the back of those HVAC systems and try to identify the refrigerant code for your refrigerator and for your air conditioners. All refrigerators and air conditioners has a refrigerant code. So as engineers and as students that are doing a course in HVAC, it is very important that you understand the different refrigerant code. Now, if you have questions, you are free to leave a question in the comment box below. Now, let's look at different compounds. Also, we have some inorganic refrigerants. We have water. We have water. We have H2O, it's water. We have H2O. H2O is an inorganic compound. We have CO2. CO2 is an inorganic compound. We have ammonia gas. Ammonia gas is an inorganic compound. These are some inorganic refrigerants that we use in HVAC systems. All right. So we can also find the refrigerant code for inorganic compounds. And the formula we use is R700 plus the molecular weights of the organic compound. We use R700 plus the molecular weights of the inorganic compound. Okay. Now we can find the molecular weight for ammonia. Let's start with ammonia. Let's find the molecular weights of ammonia. Question: calculate the refrigerant code for ammonia gas. Okay. Now let's look at this question. Look at this question. We have to find the refrigerant code for ammonia gas, and ammonia is giving us NH3. Now, before we continue, let's find the molecular weight of ammonia. Molecular weight of ammonia. You have to be good in your chemistry in this. Okay, let's find the molecular weight for ammonia. Now, N is nitrogen, and the molecular weight of nitrogen is what? Is 14. 14 plus H is hydrogen, and it's giving us 1. It has 3 atoms, so we'll do times 3. Times 3. So therefore, the molecular weight of nitrogen of ammonia is 14 plus 1 plus 3. 14 plus 1 times 3. So we have 14 plus 1 times 3 is 3. So 14 plus 3 is 17. So the refrigerant code for ammonia is 17. Now, the refrigerant code for ammonia becomes R is R700 plus the molecular weight of ammonia, which is 17 plus 17. So therefore, the refrigerant code for ammonia is R717. So this is the molecular weight for ammonia. All right, that is the molecular weight for ammonia. Now let's find the molecular weight for water. Water. Question 2. Calculate the refrigerant code for water. All right. Now, if you remember, I said that water is a type of refrigerant and it is an inorganic refrigerant. Now, step 1, the symbol for water is H2O. H2O. And step 1, let's find the molecular weight of water. Okay, so molecular weight of water. Okay, of water is, now, what is the molecular weight for hydrogen? It is given as 1. It has 2 atoms, so times 2. Oh, this is oxygen, and it is given as 16, so plus 16. Therefore, 1 times 2 is 2 plus 16. So therefore, the molecular weight of water is 18. With this, I can find the refrigerant code. Now, I said that the refrigerant code is given as R in bracket 700 plus the molecular weight, the molecular weight of the inorganic compound. So therefore, the refrigerant code for water, H2O, is what? Is R, bracket, open, 700 plus the molecular weight of water, which is 18, so plus 18. So therefore, the refrigerant code for water is R. 700 plus 18 is 718. So this is the refrigerant code for water. As you can see from this example and from this example, we can see that to identify refrigerant code for inorganic compounds, it begins with the first number is 7. So when you see R7, and some numbers, it means that it is what? An inorganic refrigerant. All right, so this is how to find the refrigerant code for inorganic compounds. If you have any question, you are free to send me a comment in the comment box, and I will respond to you as soon as possible. Also, I'll show us how to find the chemical composition of our refrigerant. Most times, what you see in the market are the refrigerant code. But as an engineer, you can be able to determine or find the chemical composition of that refrigerant using the code. Now, I'll show us this formula right here. R, X, Y, Z. R is the refrigerant. S, Y, Z represents the number of the components in that refrigerant. For example, the X is equal to X X is equal to X plus 1 plus 1. And this represents the number of carbon atoms. Y is equal to Y minus 1. And that is the number of hydrogen atoms. Number of hydrogen atoms. And also we have Z equal to Z. And Z is the number of chlorine atoms. And also, you must note that the balance is number of chlorine atoms. In this case, I'm saying that after you've gotten the values for the different components, for carbon, hydrogen, chlorine, if there is an empty space, those empty spaces are filled with chlorine atoms. I will show us what I mean by that shortly. Now, let's look at a question. Let's find the chemical composition for R22. Okay, let's look at a first example. Find the chemical composition of refrigerant 22. Okay, here's a very good example. We have to find the chemical composition for refrigerant 22. Refrigerant 22. Now, I said that X represents carbon. So, first one is X. X is for carbon. The Y is hydrogen. And the Z is what? Is chlorine. Okay. Now, to solve this, we write back this SYZ on the formula. So I can start with Z from right to left. So this is my Z. This is my Y. So my X is 0. So I have an X. So Z, so I was saying before, the SYZ represents numbers. They represent numbers. So I will start from my right. The last number is my Z, the second number is my Y, and the first number is my X. All right? So we always start from right to left. Now, X is 0. If you remember the formula, is for X is X plus 1. And my X is 0, so we have what? 0 plus 1. Remember that X, we don't have X in the code, so X is 0. So our X becomes what? 1. For Y, Y is Y minus 1. Now Y is 2. So it becomes 2 minus 1. So my Y is 1. So remember, my Z is what? Number of fluorine, and fluorine is 2. So it is 2. So fluorine is just 2. So remember that X is my number of carbon, my Y is the number of what? Hydrogen, my Z is the number of what? Fluorine. Okay? Now, what I do next is to draw this in a structural formula. Represents the values in a structural formula. I know you did in your chemistry. Represents the values CHF in a structural formula. In chemistry, what we do here is that we start with the C at the center. This is my C at the center. Then I will draw my bonds, single bonds. All right, single bonds. I have one carbon, so one carbon. I have one hydrogen. I can have one hydrogen, so I put it there. My H can be anywhere. I have two fluorine. Fluorine is 2, so I have fluorine 2, F and F. Fluorine is 2. What next? That is all. As you can see, I have one empty space. If you recall, I said that the balance is the number of fluorine atoms. So if I have a balanced space, that space is my fluorine. That space is my what? Fluorine. So this is the chemical composition of refrigerant 2,2. It has fluorine, it has carbon, fluorine. Sorry. Yes, let me write it in order. Okay, so the chemical composition can be written in this form. It has carbon, it has hydrogen, it has one fluorine, it has chlorine, it has two fluorines, so I can write fluorine 2. Alright, so this is the chemical composition of refrigerant 2,2. So you can see why refrigerant 2,2 is not good, because it has chlorine, and chlorine is not a good component in a refrigerant because chlorine destroys the ozone layer. All right, I'll show us a next example. Let's look at 2 more examples. Please don't forget these formulas. If you don't mind, I will copy them out. I'll copy them out and move them to my next slide so that we can remember these. They are very important. Okay. Now let's look at, let's find the chemical composition of refrigerant 13, refrigerant 1,3. Please don't forget this equation, very important. Please don't forget this equation, they are very important to us. Don't forget this equation. The X is the number of carbon, the Y is the number of hydrogen atoms, Z is the number of fluorine. Now, I was saying that in my last example, the first thing we do here is that we start from right to left. The last number is my Z. The second number from my right is my Y, and X is 0. X is 0. So my X is equal to what? X is 0 plus 1, which is 1. And Y, now Y is what? Y is 1. As you can see, Y is 1. So the formula is Y is 1 minus 1. So Y is 1 minus 1. Now Y is 0. So I have 0 hydrogen atoms. My Z is 3. Z is 3. Z is 3. Okay. Now I want us to remember that my X is my carbon, my Y is my hydrogen, and my Z is my fluorine. Okay, so what next? I will represent this on a structural formula. So it becomes, in chemistry, we start with C. All right, start with C. So it becomes, I start with C. Okay, draw my single bonds. As you can see in this question, my hydrogen is zero. My hydrogen is zero, so I will not write it here. My fluorine is 3, so fluorine is 3, fluorine. Then the marker. Okay. My fluorine is 3, so fluorine 1 fluorine here, 1 fluorine here, 1 fluorine here. So guys, it doesn't matter how you arrange it. So fluorine is 3, and as you all know, my hydrogen is 0, so we have no hydrogen. So now I have one empty space. Remember this, the balance is the number of fluorine. So I will write chlorine in this space. All right. So this is the structural formula for refrigerants 1, 3. So I can write it in clear form. It becomes carbon, fluorine. We have 3 fluorine, 1, 2, 3, F subscript 3. All right. So this is the chemical composition for refrigerant 1, 3. Okay, I will show us one more example. I will show us one more example of how to find the chemical composition of compounds. Okay, now let's look at let's find the chemical composition for refrigerant 134A. 134A. Please remember the formulas we use. Always remember these formulas. Now, when finding the chemical composition for refrigerant, we don't include the numbers. All right. I said that S, Y, Z represents numbers, not letters. So I will start my Z. I will start from the right. So the last number is my Z. All right. The second number from the right is my Y, and the number here is my X. So in this case, my X is 1, my Y is 3, my Z is 4. What next? I will put these values into my formulas. So for my X is 1, so X is 1 plus 1. So 1 plus 1 is 2, 1 plus 1 is 2. All right. What next is my Y? My Y is 3, so it becomes 3 minus 1. So Y is 3 minus 1. That is 2. My Z is 4, so my Z is 4. My Z is 4. All right, cool. Now, if you remember clearly, I said that my X is the number of carbon, my Y is the number of hydrogen, and my Z is the number of fluorine. Okay. Now, what do I do next? I will draw the structural formula. Okay. So I will start with my carbon. Right here, I have 2 carbon. As you can see, we have 2 carbon. So I'll draw carbon 1, 2. Draw my bonds, very important. What next? I look at my hydrogen is what? Is 2. So I can put in 2 hydrogen. Okay. What next? I have I have 4 chlorine. Sorry, I have 4 fluorine. Fluorine is 4. So fluorine 1, 2, 3, and 4. So I have 4 fluorine. As you can see, in this case, there is no balance. There is no space for fluorine atoms. So as you can see, refrigerant 134 has no fluorine. That is why refrigerant 134 is a good refrigerant, and it is used today in most HVAC systems because refrigerant 134 has no chlorine content. Alright, so I can make this look good. So I have 2 carbons, I can say 2 carbons, carbon 2, carbon is 2. I have 2 hydrogen, hydrogen is 2, H2. I have 4 chlorine, 4 fluorine. Fluorine is 1, 2, 3, 4. I have 4 fluorine, fluorine is 2. So this is the chemical composition of refrigerants 1, 2, 4, 8. If you can check your fridge, your refrigerator, or check your AC, you'll be surprised that the refrigerant it is using is refrigerant 1348, or it can be using also refrigerant 22. But in the next few years, refrigerant 22 will be phased out due to the chlorine content in them. So this is how we find the chemical composition of some refrigerant codes. If you have any question, you are free to send me your response on the comment box, and I will respond to you as soon as possible. Thank you very much, and have a blessed day. Bye.